everyone, and good day everyone. We are Group 2, presenting heavy reinforced concrete, pre-stressed concrete, and steel construction. And by the way, I'm Franz Christian Elrod Rocks, and I hope you enjoy our presentation. The first topic of heavy reinforced concrete, pre-stressed concrete, and steel construction will be foundation systems. Foundation systems transfer the lateral loads and superstructure to the ground. The horizontal component of these lateral forces is transferred largely through a combination of soil friction at the bottom of footings and the development of massive soil pressure on the sides of footings and the foundation walls. Foundation systems are classified into two broad categories: the shallow foundations and deep foundations. Shallow foundations, or spread foundations, are employed when stable soil of bearing capacity occurs relatively near the ground surface. They are placed directly below the lowest part of the superstructure and transfers building loads directly to supporting soil by vertical pressure. Types of shallow or spread footings are individual or isolated footings, strip footings, and combined footings. Individual or isolated footings are spread footings, supporting freestanding columns and piers. There are three illustrations of footings, and these are the blocks or square footings, step footings, and slope or pyramidal footings. Number 2, strip footings are the continuous spread footings of foundation walls. Step footings are strip footings that change levels to accommodate the sloping grade and maintain the required depth at all points around the building. Combined footings can support two or more columns. This type of footing is used where it is not possible to center the footing beneath its supporting column, as in the case of columns located at or very near the property line. Combined column footings are usually rectangular and trapezoidal in shape. Cantilevered footings. This type of footing may be used in place of combined footing under the same condition. This type of construction, the footings of the exterior and interior columns are connected by a tie beam or strap which is so extended to support the exterior column. Continuous footings. Continuous footings may be supporting a line of columns or supporting all of the columns by strips at right angles to each other. They may be inverted slab or inverted T-continuous footings. Mat or rock foundations. Mat foundations and continuous footings are used on soil of low bearing power where there is tendency towards unequal settlement due to unequal loading of soil. This type of foundation, all parts of foundations are so tied together so that they will act as one and assist each other when keeping level in plumb. Mat foundations may be divided into the following general classes: pad slabs of plain or reinforced concrete, beams or girders with slab underneath, beams or girders with a slab on top. Steel grillage foundation. When it's desired to avoid the deep excavation required for concrete and masonry footings, and when the load has to be distributed over a wide area of support, steel rails or beams are used to give the required moment of resistance with a minimum of depth. Deep foundations are employed when the soil underlying a shallow foundation is unstable or of inadequate soil-bearing capacity. They extend down through unsuitable soil, transfer building loads to a more appropriate bearing stratum of rock or dense sand and gravel well below the superstructure. Types of deep foundations are pile and caisson foundation. Pile foundation is a system of end-bearing or friction piles, pile caps, and tie beams for transferring building loads down to a suitable bearing stratum. End-bearing piles depend principally on the bearing resistance of the soil or rock beneath their feet for support. Friction piles depend principally on the frictional resistance of a surrounding earth mass for support. Wood piles, when it is required to build upon a compressible soil saturated with water and of considerable depth, the most practicable method of obtaining a solid, enduring foundation for buildings of moderate height is by driving wooden piles. That's right. Wooden piles are made from the trunks of trees and should be as straight as possible and not less than 5 inches in diameter at small end for light buildings or 8 inches for heavy buildings. The piles are driven by means of a drop hammer or with a steam hammer, a succession of blows being given with a block of cast iron or steel called the hammer, which slides up, down and down, which slides up and down. The uprights of the machine is placed over the pile driver. The machine is placed over the pile so that the hammer descends fairly on its head. The pile is being driven in small and down. And this wood file would be continued by Miss Mary Joy Sabito. Take it away, Mary Joy.
Thank you, Franz. Hi everyone, my name is Mary Joy D. Sabido, and I will continue what Franz Raut discussed. In driving wooden piles with a drop hammer, it generally raised by steam power and dropped either automatically or by hand. The weight of the hammer used for driving piles for building foundation is usually from 1,500 to 2,500 pounds. Steam hammer are to a considerable extent taking the place of the ordinary drop hammer as they will be driven more piles in a day and deliver quick short blows from 6 to 70 minutes. Driving piles care should be taken to keep them plump, and when the penetration becomes small, the fall should be reduced about 5 feet, the blows being given by rapid succession. When the penetration is less than 6 inches at each blow, the top of the pile should be protected from brooming by putting on an iron pile ring. Pile ring, also called a driven band, a steel band which encircles the head of timber pile to prevent from splitting when being driven. Driving in soft and silty soil, it's better with a square point. This usually in the form of cast conical point about 5 inches in diameter, secured by a long dowel with a ring around the end of the pile. The pile should not be spaced less than 2 feet uncentered. Usually, spacing is from 2 to 3 feet. When long piles are driven closer to 2 feet on center, there is danger that they may force each other up from their solid bed on bearing stratum. The usually practice is use the reinforced concrete cap. The method is being excavate 6 to 12 inches below the top and 1 foot outside of the piles. Heavy timber grillages may also be used for capping. The timber for the grillages should be at least 10 times 10 inches in a cross section and should have sufficient transverse strength to sustain the load from center to center of piles. They should be laid longitudinal on top of piles and fastened to them by means of drift bolts. Drift bolts, a short rod or square bar driven into holes bored in timber. For attaching adjustments, stick for each other or to piles. Varies from 1 to 2 feet, 300 to 600 millimeters in length, often provided with a head or with a sharpened end, also called a drip or drip pins. Concrete piles. Concrete piles, either plain or reinforced, possess many advantages over wooden piles. Can be used in all places where wooden piles can be driven. A use where wooden piles would be subject to decay or deterioration by the action of marine worms. There are two general types of reinforced concrete piles. Spacing for concrete piles, usually from 2 to 6 to 4 inches concrete piles are extended at least 4 inches into the concrete of the footing, and where a steel casing surrounds the pile 3 to 4 inches. Precast piles. Precast piles, they are usually molded in a yard or at a site allowed to cure for 4 weeks before using. In driving, a precast pile is provided with a cast iron point and a driving head is used which cautious of sand, rope, or other materials is placed between driving block of wood and the concrete is ordered to prevent the crushing of the pile. Concrete piles are often soaked by means of water jet. The method is made possible by inserting an iron pipe in the center of pile. Cast-in-place piles. Cast-in-place piles are constructed in the ground in the position they are to occupy and often reinforced. Practically all cast-in-place piles are covered by pantents. A cast-in-place pile may be formed by any of the following method. A hollow cylindrical steel tube, usually furnished with a tight-fitting collapsible steel core or module, is driven into the soil. The core is then collapsed and removed, and the steel shell filled with concrete. Thus, there is a shell or form of pile of MacArthur piles, Raymond piles. This use a number 24 gauge shell in which a spiral of number 3 wire is encased. This is commonly called case pile. A steel tube is fitted at the bottom with driving point. The driving point may be either a conical cast iron point that left in a place or a hinge cutting edge called a ligator point with often as a tube withdraw. Simplex piles. This is called uncased piles. A steel pipe or a shell is first driven into the ground. This driven core is then removed and the bottom of the shell filled with concrete to a height of about 5 feet from the bottom. Pressure is applied to force out the concrete into the surrounding soil as the core withdraws. And these are known as pedestal piles. Steel piles. These are a concrete filled steel pipes which are made to bear on rock or hard pan. The pipes are generally 10 to 18 inches in diameter, having a thickness of 3 to 8 to 5/8 inches. Composite piles. These are combination timber and concrete or steel and concrete piles. They have been composed of timber piles with concrete coating held in position by steel reinforcements in the shape of expanded metal or wire netting. The latter are to be considered as timber rather than concrete piles. Caisson foundation are cast in a plain or reinforced concrete piers formed by boring with a large auger or excavating by a hand a shaft in the earth to sustainable bearing stratum and filling the shaft with a concrete For this reason, they are also referred to as drilled piles or piers. So let's Randy Reyes continue this report. Ran?
Thank you, Mary Joy. Again, my name is Renly Tagulimot Reyes. So I'll be discussing to you the foundation walls, basement construction, and cisterns. First, we discuss about foundation walls. So foundation walls provide support for the superstructure above and enclose a basement wall or crawl space partly or wholly below grade. In addition to vertical loads from the superstructure, foundation walls must be designed and constructed to resist active earth pressure and anchor the superstructure against wind and seismic forces. So, as you can see in the picture, you will see the wall system, slow finish grade to drain surface water, floor system, positive anchorage required to resist. There is damp proofing or waterproofing, active soil pressure, cast and place concrete or concrete masonry units, and subsoil drainage system, also concrete ground slab, and size of footing is based on the foundation wall loads and allowable soil bearing capacity. So, at the other picture, you will see the sample of basement walls and section of cistern. Next, reinforced concrete column. There may be short column or long columns. Short columns occur when the unsupported height is not greater than 10 times the shortest literal dimension of the cross section, and the long columns occur when the unsupported height is more than 10 times the shortest lateral dimension of the cross section. So, there are some types of RC columns. First is tied columns. These are columns with longitudinal bars and lateral ties. The ratio of the affected cross-sectional areas of vertical reinforcement to gross column should not be less than 1% nor more than 8%, and should consist of at least 4 bars of a minimum size of number 5. So next is spiral columns. These are columns with longitudinal bars and closely spaced continuous spiral hooping. For spiral columns, the ratio of the area of vertical reinforcement to the gross column area shall not less than 1%, nor more than 8%. The minimum number of bars shall 6, and the minimum bar size shall number 5. So the third one is composite columns, where structural steel columns are embedded into the concrete core of a spiral columns. Next is combined columns, where structural steel is encased in concrete of at least 7 cm thick, reinforced with wire mesh surrounding the column at a distance of 3 cm inside the outer face of the concrete cover. So the last is the lily columns, are fabricated steel pipes provided with flat steel plates which hold girder or dirt and filled with grout or concrete to prevent corrosion. So that's all the 5 types of RC columns. So next, we have dowel bars. Dowel bars are short bars used to transfer the stress at the bottom of the columns to the footings. When dowel bars are used, there should be at least one dowel bar for each column bar. The total cross-sectional area of dowels should not be less than the cross-sectional area of longitudinal reinforcement in the column. The dowels shall extend into the column and into the pedestal or footing not less than 50 bars diameters for plain bars or 40 diameters for deformed bars. So next, we tackle about reinforced concrete floor system. In general, there are 6 types of reinforced concrete floor systems. First is one-way solid slab and beam. Next is one-way joist, slab or rivet slab, 2 solid slab and beam, 2-way waffle slab, 2-way flat plate, and 2-way flat slab. Each particular system has its distinct advantages, depending upon the spacing of columns, the magnitude of the loads to be supported, lengths of spans, and the cost of construction. Although the arrangement of the plans of building frequently determines the column spacing approximately squared by a desirable column spacing of 20 feet more or less has proved to be most economical, but this of course depends on type of floor construction to be used. So next, first we have one-way slabs. Probably the most commonly used type or reinforced concrete construction consists of a solid slab supported by 2 parallel beams. The beams framing into girders and the girders into framing and 2 columns. The reinforcement slabs runs in one direction only, from beam to beam, hence the slabs and known as one-way slabs. This is the type framing, also called the beam and girder floor. It is readily constructed and the formwork is simple. The one-way slab is economical for medium and heavy loads for comparatively short span 6 to 12 feet. For light lead loads 40 to 60 psf, the spans may be increased, but long spans for one-way slabs result in comparative large lead loads. The main tensile reinforcement running along the short direction in fully continuous slabs are alternately bent up, usually at an angle of 30 to 45 degrees at the feet points of the span and extended over the supports to quarter points of a joining span. In addition to the tensile reinforcement, temperature bars are also provided running along the long direction. This serves to provide against the effect of shrinkage and changes in temperature, and also to distribute possible load concentration over larger areas. The size and spacing of temperature bars depends upon the slab thickness. So, and next slide, Jeanette Bass will continue discuss about this topic. Thank you, everyone.
The minimum protective per slab covering measures about 20 millimeters or 3/4 inches. This one-way slab is supported on 2 sides by beams. Beams may be supported by girders or columns. Here we have a section of a slab. As seen, we have a distinct end right here. It is called a discontinued end. And right here, it is called a continuous end, since it is connected by another end. One-way joist or rib slab. Bakit nga ba rib slab yung tawag? Well, it sort of looks like a rib, where there are multiple supports to it. Rib slabs may have proven to have an economical type of floor construction. It consists of relatively small adjacent T-beams that when the open area between the webs or rings are filled with clay tile, gypsum tile, concrete pillar, or steel forms, the floor system then is called a rib slab. The distribution rib is formed perpendicular to the joist in order to distribute possible load concentration over a larger area. Here we have a closer diagram where we can see the pan. These pans are what we call molds. They are easier to remove by the sides and they are quite reusable. Let's talk about the pillars for the slab. The first one is the clay tile pillars. Generally, they are 12 inches by 12 inches with depths of 4, 6, 8, 10, 12, and 15 inches. These type of reinforcements in construction may consist of 2 bars in the lower part of the web, 1 bent and 1 straight, or just straight bars that are placed top and bottom part of the web. The metal fillers are frequently used for rib floors. It is commonly known as the tin pan construction. Metal forms are placed on centers in such a manner to make a web. The metal forms may be removed or left in place, or after supporting formwork that has been taken down. To provide a greater web area near the supports, where there are shearing, stresses may exceed the allowable. Special metal cores with sides tempered in plan are used. Gypsum tile pillars have a advantage of providing relatively lightweight ribbed or flushed ceiling. Removable steel forms. This is the C-joist, the 6mm wire mesh, removable steel form or the RSF, the concrete slab, wood stiffener. Two-way slab is generally economical to use 2 sets of reinforcing bars placed at right angles to each other. These bars in 2 directions transfer the loads to the 4 supporting beams. 4 walls. Thus, two-way slab or slab supported on floor sides. For square panels with supports of equal rigidity, the live and dead bolts are distributed equally in both directions. The reinforcements are semi-tray. For panels that are rectangular or oblong shape, the greater the part of the load is transmitted by the transverse or short reinforcement. The entire load is usually assumed to be carried by the short reinforcement and the long reinforcement used for shrinkage and temperature reinforcement only. Hence, the slab would become a one-way slab. In determining the reinforcement of a two-way slab, 2 strips of floor are considered. The first one is the middle strip. The middle strip has 1/2 of the panel in width, symmetrical about the panel center line, and extending through the length of the panel. The second one, is the common strip. This is also 1/2 of the panel in width but occupying a quarter panel area outside the middle strip. two-way slab are most efficient when spanning square or nearly square base and suitable for carrying intermediate to heavy loads. Here we have Joshua Justiniane for the next topic.
Two-way waffle slab. A waffle slab is a two-way concrete slab reinforced by ribs in two directions. Waffle slabs are able to carry heavier loads and span longer distances than flat slab. Or should I say, a waffle slab, also known as a two-way joint slab, is a reinforced concrete slab with concrete ribs running in two directions on the underneath. The rig patterns generated by the reinforcing ribs gives the waffle its name. Two-way flat plate. A flat plate is a concrete slab of uniform thickness reinforced in two or more directions and supported directly by columns without beams or girders. Simplicity of forming, lower floor-to-floor heights, and some flexibility in column placement make flat plates practical for apartment and hotel construction. Or should I say, the two-way flat plate slab is essentially a slab of uniform thickness supported directly on columns, and it is best suited to light weights. With reinforced concrete, two-way flat plates can span up to 8 meters and with the post-tension method up to 11 meters. Two-way flat slabs. A flat slab is a flat plate thick at its column supports to increase its shear strength and moment resisting capacity. The slab is commonly reinforced with bars running in two directions. This area of increased thickness is called a drop panel or drop. Flat slabs floors are economical in use of material and provide a rigid type of constructions. These floors are particularly suitable for industrial buildings having large loads and for buildings in which the columns capitals are not objectionable. Among the advantages claimed for a flat slab floor are the simplified formwork, better lighting due to the absence of beams and girders, a saving in a height for a given clerestory height, a uniform surface for suspending sprinkler systems, piping and shafting, and because of the absence of sharp corners, better resistant to fire. There are several methods of reinforcing flat slabs and flat plates. Number 1. Two-way system. This system is the most commonly used and consists of two sets of bars extending directly from column to column in both directions. Slabs are square or rectangular. Number 2. Three-way system. The reinforcement extends from column to column, the columns being placed at the corners of equilateral triangles. Hence, slabs are triangular in shape. Number 3. Four-way system. The reinforcement extends both directly and diagonally between columns in both directions. The slabs are square or rectangular. Reinforced concrete beams. A beam may be defined as a structural member resting on a support, usually at its ends, which supports transverse loads, the loads that act on the beam as well as the weight of the beam itself tend to bend rather than lengthen or shorten it. A girder is a term applied to beam that supports one or more smaller beams as a concentrated loads. So, I'll give you to Jillian Padua on the classification of beam.
Hello everyone, welcome to the part of my vlog. So finally, it's the last part of the vlog, so just wait there. Okay, so without any further ado, let's start. There are 3 classified beams. Beams are classified in 3. There is simple beam, cantilever beams, continuous beams. So I will provide a picture here. Ouch. Simple beam. Simple beam, these are beams having a single span with a support at each end, there being no restraint at the supports. cantilever beams. These are beams that are supported at one end only, or they may be part of a portion of beams projecting beyond one of its supports. So, para siyang nakadikit lang siya sa one side. Or parang isa lang talaga yung support niya dito, no? Tchanan! Ganun. Continuous beams naman are beams resisting on more than two supports. So, parang may multiple supports siya. So, that is continuous beams. So, when a beam is subjected to a given load, the beam is bent downwards at the middle. So, if nasosobrahan na yung beam, magbe-bend yan ng paganon. If nasosobrahan na siya sa dinadala niyang weight, so, nagbe-bend siya. The lower part of the beam is being elongated pag nagbe-bend siya, while the upper part of the beam is compressed. The lower part of the beam is said to be in tension. So, ilalagay ko na din naman yung picture here. So, yung upper part is compression. So, what is compression? Compression yung paganon. Yung force mo. Ganun. Tapos yung tension naman is parang nagsa-stretch. Okay? At the supports, however, the upper surface of the beam becomes concave downward. That is, there is a reversal of stresses. The upper portion of the beam is now in tension, or the bending moment is said to change from positive to negative. The section of a beam at which the bending moment changes from positive to negative is called the point of inflection. So, as you can see naman here sa pic, is parang nagpa-concave curve siya, ganun. Tapos, concave downward siya. So, as you notice, yung parang green na may dot, yun yung point of inflection. So, yung point of inflection na yan is nagdi-depend sa magnitudes of the loads as well as the end conditions of the beams. At this point, some of the reinforcing bars are bent up at an angle of 40 to 45 degrees. Ano ba? 45, 40, basta. And extend over the supports into the adjacent spans. The bent up bars serve to resist the tensile stresses over the supports. So, if nakikita nyo sa picture dito, yung bent up bars, yung nakikita nyo is parang na ganun. It's bent up bars for a reason kasi nakabend siya. Parang na-diagonal siya. Nakabend siya. Tapos, what this does, ay nakabend siya in 30 to 45 degrees. So, what this does is parang it's an additional support na din sa beams. Because it says here, the bent up bars serve to resist the tensile stresses over the supports. So, parang it's an additional support na din to the reinforced beams. Another method naman is to use separate straight bars in both the bottom and top of the beams in place of bent bars. So, kagaya nung sa picture dito. In addition to tensile and compressive stresses in a beam subjected to bending, there are also inclined tensile stresses. So, parang in a beam, nagbe-bend siya, it's because of tensile and compressive stresses. So, it's the stress. If a concrete beam is reinforced with longitudinal steel only, these diagonal stresses tend to produce cracks. So, parang it produces, eventually, nagproduce siya ng cracks. The stresses that cause these cracks are known as diagonal tension. So, ang cause ng pagka-crack niya is called diagonal tension. So, as you can see naman sa picture, those cracks is because of tensile and compressive stress. Kaya nagka-crack siya ng ganon. There are also there are inclined tensile stresses. Basta may crack siya, ganon. And then the cracks there are caused by diagonal tension. So to prevent this, To prevent failure due to diagonal tension, additional reinforcing bars are used. So, para ma-avoid natin yung mga ganitong problema in construction, may dadagdag tayong reinforcing bars. So, the usual procedure is to add number 4 or number 3 bars, bent in the shape of the letter U. These bent reinforcing bars are called stirrups. They should always have hooks at the end to provide anchorage to resist the tensile stresses. So stirrups yung the usual procedure to prevent the cracks or the bending. So ngayon naman, ipapakita ko sa inyo in a table diagram here yung proper width of beam na may kasalungat niyang number of bars. So here, this is the diagram. So nakita niyo dyan, width, tapos yung mga numbers sa ibaba, yun yung number ng bars at specification ng bars. So thus, for instance, in a 12 inches beam, makikita niyo sa bandang huli doon. So, in a 12 inches width beam, pwede kang magamit ng 4 ka number 9 bars. Pwede po 5 ka number 6 bars, 6 ka number 4 bars. So, lastly is we are going to discuss the types of reinforced concrete beams. So, may types pala. May types yung reinforced concrete beams. So, one is the rectangular beams, which are the most common beams or yung ginagamit always. So, the rectangular beam is those which have a cross-section rectangular shape. Rectangular beams nga, so dapat rectangular din yung shape, di ba? These types of beams generally experience tension at the bottom and compression at the top. So, yun yung sinabi ko the last slide na tension is at the bottom, and compression is at the top. Okay? Rectangular beams are the most common types of beams used in a building construction from small houses construction to high-rise building construction. So, ito yung always na ginagamit. T-beams. The beam has a cross-sectional shape like a T. So, kaya tinatawag siyang T-beam kasi it's formed like a T, which is called a T-beam. This beam is generally cast monolithically with the slab. As a result, the slab acts as a integral part of the beam and bends in the longitudinal direction of the beam. The slab portion is called flange for T-beam. The beam portion below the flange is called the web. So next, beam with compression reinforcement. So this is the third beam with compression reinforcement. These are beams with reinforcement in the compression as well as the tension side of the beam. Hence, they are also called double reinforced beams. So this is also called, or aka, double reinforced beams. In this type of beam, no bent bars are required. So, hindi siya nagre-require ng bent up bars. So, naalala niyo yung bent up bars? Bent up bars is yung bars na naka-bend 30 to 45 degrees. And it adds as a support sa beam. Okay. Next, cantilever beams. The tensile reinforcement is located at the top of the beam and inverted U-strips are provided. So, hindi ko masyado naiintindihan to. Basta yung picture, ilalagay ko na lang dito. Next, hollow box grinders. These are double reinforced beams used for long spans. In order to reduce the dead load, the weight of the beam, it is hollowed in the center of the section. Diaphragms are provided at intervals throughout the length of the beam. So, as you can see sa picture na ito, these are the types of beams na pang matagalan. Like ni-search ko sa Google, tapos yung lumabas doon is mga bridges. So, bridges, di ba, pang matagalan yung lifespan nun. Dapat lang. So, parang it's a kind of beam na hollow yung gitna. So, yun yung hollow box grinders. Okay. Next, beam brackets or corbels. Short beam extensions for columns used to support rafters or trusses. So, ito yung picture. Okay. Beam brackets or corbels, short beam extensions. So, the corbels or beam brackets is parang extension lang talaga siya. Pero, extension siya in a way na na-attach sa columns. Kasi sa columns siya na-attach. Kasi extension lang talaga siya. Pero sinusupport niya yung beam. So, kaya siya tinawag na beam extension. So, dito ko na lang tatapusin yung discussion namin. And I hope na may natutunan kayo. Thank you so much for listening. And this is Group 2 signing off. Neneng, takpan mo na!